Now here's something that looks a little more difficult. 100 over x minus 100 over x minus 5 equals 2 over x. But if we use our strategy of always multiplying by an LCM, it gets easier. And what is the LCM? It contains the denominators. You've got two denominators here that are identical. So really, you've only got two denominators, x and x minus 5. That is, you have two different denominators. So I multiply them together. And I'm not even going to distribute because why make life hard? I'm going to let my LCM be x times x minus 5. And then I'll multiply 100 over x by x times x minus 5, minus 100 times x minus 5 over x minus 5 equals 2 times x minus 5 over x. And then I cancel my denominators. Here the x's cancel, and I'm left with 100 times x minus 5. Here the x minus 5's cancel, and I'm left with minus 100x. And over here the x's cancel, and I'm left with 2 times x minus 5. When I distribute 100 times x, 100 times minus 5, I'll have 100x minus 500 minus 100x equals 2x minus 10. Over here, 100x minus 100x equals 0. So that leaves me with minus 500 equals 2x minus 10. And then to get my constant terms together, I will add 10 to both sides of the equation. Negative 500 plus 10 is negative 490. Meanwhile, negative 10 plus 10 is 0, so I'm left with 2x over here. Negative 490 equals 2x. I divide by 2, and my answer is 245. That's what x equals. LCMs are better than chocolate chip cookies. Oh, well, they had to get more difficult, didn't they? Here we have denominators, but I am not able to know what my LCM is until I factor all my denominators. So x squared minus 7x plus 6 is x minus 6 times x minus 1. X minus 6 is already in factored form, and 4x minus 4 is 4 parentheses x minus 1. These are the factors I have in my denominators. I've got an x minus 6, I've got an x minus 1, and I've got a 4. I put these together right here, and that's my LCM, my least common multiple. I then proceed to, here, let me do this. Multiply by my LCM by 6, multiply by my LCM by 1, and multiply by my LCM by 1. But I'm careful to leave everything in factored form. Okay, so here I multiply 6 by 4 times x minus 6 times x minus 1. I leave x squared minus 7x plus 6 in factored form so that the x minus 6's cancel and the x minus 1's cancel. That leaves me with 6 times 4, which is 24. Over here, the x minus 6's cancel, so I'm left with a minus. 1 times 4 is 4 times x minus 1. And over here, my 4's cancel, my x minus 1's cancel, so I'm left with 1 times x minus 6, which is x minus 6. So I'll have 24 minus 4x plus 4. I have negative 4 times negative 1, that's plus 4, equals x minus 6. 24 plus 4 is 28, minus 4x equals x minus 6. I decide to move my 4x over here with the other x term, so I'll have negative 4x here, but I add 4x here. That gives me 0, or 0x over here. I add my 4x over here. 4x plus x is 5x. Then I move my minus 6 over to the other side, so it'll be with the other number. And so I'll have negative 6 plus 6 equals 28 plus 6. I've got 34 equals 5x. I divide by 5, and my answer is x equals 34 over 5. Piece of cake when you have an LCM. Okay, you factor first so you'll know how to construct your LCM. I have a z minus 3 and a z plus 3, and I have a 4, that goes into 36. So 4 times z squared minus 9, that will be 4 times z plus 3 times z minus 3. So the factors that make up my denominators are 4 and z plus 3 and z minus 3. And to form my LCM, all I do is multiply these 3 factors. Now make sure you've written another line with your denominators in completely factored form, because your LCM in factored form is going to cancel out the denominators. That's its job. That's what it does. Here the 4's cancel, z plus 3 cancels, and z minus 3 cancels, leaving you with 1. Over here, only the z minus 3's cancel, so you're left with 3 times 4, which is 12, times z plus 3. And over here, the z plus 3's cancel, so you're left with 6 times 4, which is 24, times z minus 3. Okay, before I do anything else, I'm going to distribute the 12 into there. Distribute, distribute, and I'm going to distribute my 24. Distribute, distribute. That will give me 1 plus 12z plus 36, which will give me 1 plus 36 is 37. I'll have 12z plus 37. Over here, I'll have 24z minus 72. And then I decide, well, golly gosh, I think I'll move my 12z over here with the 24z. So I'll subtract 12z from both sides of the equation. 12z minus 12z is 0. I'm left with a 37 over here. 24z minus 12z is 12z, and I still have my minus 72. Then I decide to add 72 to both sides of the equation, leaving me with 12z equals 109. Then I divide by 12 and divide by 12. So I have z equals 109 over 12. Now, we move on. My square root is already isolated, so I'm going to square the left side of the equation and the right side of the equation. When I square the left side of the equation, I get x minus 4 times x minus 4. Don't be fooled and say x squared minus 16 or x squared plus 16. You have to do this. However, when you square a square root, you get what's called the argument, what's underneath the radical, x minus 2. Now, let's multiply this. We'll get x squared minus 4x minus 4x plus 16 equals x minus 2. Minus 4x, that's minus 8x. So we have x squared minus 8x plus 16 equals x minus 2. Now this is a quadratic equation. So that means I have to use the zero principle. I'm going to subtract x from both sides of the equation, and I'm going to add 2 to both sides of the equation. Over here, I get 0 plus 0, which is, yeah, it's 0. Over here, I'll get x squared minus 9x plus 18. So x squared minus 9x plus 18 equals 0. Now this is a quadratic equation, and so far the only method you've got for solving a quadratic trinomial is factoring. Luckily, our leading coefficient is 1. So we get to use an easier method than grouping, and that always makes me happy. X. Now 18, negative 6 times negative 3 will add together. Let me finish my sentence there. To give me negative 9. So minus 6 minus 3. And then I set each factor equal to 0 and solve for x. Let me scroll this up. Add 6 to both sides. I'll have x equals 6. Add 3 to both sides. I'll get x equals 3. So you want to say that x equals 6 and 3. But this is a radical equation and you just don't know. Here are your possibilities. 6 and 3 might both be solutions of the equation. Or 6 and 3 might both be extraneous. I've seen it happen. Or 6 might be a solution and 3 might be extraneous. Or the other way around, 3 might be the solution and 6 might be extraneous. You don't know. So we're going to find out. X minus 4 equals the square root of x minus 2. Okay, that's true. And x minus 4 equals the square root of x minus 2. Now this is how I'm going to check my answer. This side I'm going to let be x equals 6, and I'm going to let this side be x equals 3. Okay, so 6 minus 4 equals the square root of 6 minus 2. 6 minus 4 is 2. The square root of 6 minus 2 is the square root of 4. The square root of 4 is 2, so we have 2 equals 2, which is true. That means 6 is a solution. Now let's come over here and check. X equals 3. 3 minus 4 equals the square root of 3 minus 2. 3 minus 4 is negative 1, equals the square root of 3 minus 2 is positive 1, and the square root of positive 1 is 1. So we have negative 1 equals positive 1, which is not true. In fact, it's false. They're two different numbers, which means x equals 3 is extraneous. So what you're going to do is you're going to have x equals and an answer box. You're not going to put in two answers, 6 and 3. You're just going to type in the number 6. That's it. This is the only solution. 3 is extraneous. Always check your answers. Okay, here we have another equation. The square root of x plus 7 plus 5 equals x. I need to isolate my square root, so I'll subtract 5 from both sides of the equation. That gives me the square root of x plus 7 equals x minus 5. Then I need to get the radical off of the x, which here is paired with an x plus 7. It's part of a binomial, so they're stuck together, at least under the radical. Okay. Yeah, the only way to free up the x is to square the square root. So I'll have the square root of x plus 7 squared equals x minus 5 squared. The square root of x plus 7 squared is just x plus 7. X minus 5 squared is x minus 5 times x minus 5. So x plus 7 equals x squared minus 5x minus 5x plus 25. So x plus 7 equals x squared minus 10x plus 25. This is a quadratic equation, so I set these guys to 0 and move them over here. Minus x, minus x, minus 7, minus 7. Here we'll have 0 plus 0. Over here we'll have x squared minus 11x plus 18. So 0 equals x squared minus 11x plus 18. Now, I've got a 1 leading coefficient, so I make empty parentheses. Don't have my coffee with me. X. 18 equals negative 9 times negative 2, and negative 9 plus negative 2 is negative 11. So minus 9 and minus 2. So, yes, okay. So there are my factors. Negative 9 plus negative 2 is negative 11. Negative 9 times negative 2 is positive 18. Now I set each factor equal to 0. You know all about that. I usually only need 3 lines. X minus 9 equals 0. X minus 2 equals 0. Plus 9. Negative 9 plus 9 is 0. So X now is by itself equals 9. And over here, plus 2. X equals 2. Now we have to check the answers. So I have to go up here. Okay. Write down the original equation. The square root of x plus 7 plus 5 equals x, and the square root of x plus 7 plus 5 equals x. And I'll use this side for x equals 9, and this side for x equals 2. And then I'll scroll up so I can see what I'm doing. And you can too. All right, if 9 is x, this is what I do. 9 plus 7, square root of 9 plus 7, plus 5 equals 9. And over here, the square root of 2 plus 7 plus 5 equals 2. Okay, the square root of 9 plus 7, that's 16. The square root of 16 plus 5 equals 9. The square root of 16 is 4, so 4 plus 5 equals 9, and it does. 9 equals 9. So this is true. 9 is a solution. Now let's come over here and try the 2. The square root of 9 plus 5 equals 2. Square root of 9 is 3. 3 plus 5 equals 2. 8 equals 2. No, it doesn't. That's false. And that means x equals 2 is extraneous. Oh. U-S. Notice that the first 5 letters of extraneous they spell extra. That's what extraneous means. Anytime you square both sides of an equation, you're in danger of getting an extraneous solution. So you have to be very careful and check your answer. Here's a pendulum. It swings to the left, swings to the right. We're going to be talking about the period of a pendulum. The period is, you take your pendulum and you pull it over here and you let it go. So it swings over here and then it swings back. Let me do it with this. You pull it over here, you let it go, it swings as far as it can over here, and then swings as far as it can over here. That is one period. You let the pendulum go, and it swings, and when it comes back to where it started, not down here, but to where you started it, that is one full period. T is the letter because it's time. T is the letter for the time of a period, of a pendulum. So this is Yeah, let's write period over here. Okay, and let's read what this stuff is. The formula T equals 2 pi times the square root of L over 32 can be used to find the period T in seconds of a pendulum of length L in feet. What is the length of the pendulum that has period 2.8 seconds? And it tells you to use 3.14 for pi. Okay, so the period is in seconds. And the length of the wire that's in feet. So it's a big pendulum. Not a little pendulum like this. So this is going to be in feet. And this will be in seconds. Now, they're telling us that the length of a pendulum, the period is 2.8 seconds. Okay, we've got T equals 2 pi times the square root of L over 32. Now this is not as hard as it looks. Be calm. So T is going to be 2.8 equals 2 times 3.14 times L over 32. So 2.8 equals 6.28 times the square root of L over 32. Let me make absolutely sure that I've got that right. Yeah, square root of L over 32. Now, I divide both sides by 6.28. 6.28. So we're going to have 2.8. Don't put it in your calculator yet, because every time you use your calculator, you build up a little more error every time. Error. You build up enough, you'll get the wrong answer, and my math lab will tell you, oh, sorry. You don't want that. So what we're going to do is this. I'm going to put parentheses around this and square it, and parentheses around this and square it. But I'm not going to put that in the calculator yet. I will. I promise. 2.8 over 6.28 squared equals L over 32. Now I'm going to be solving for L. So that means I'm going to multiply both sides of this equation by 32. Boom, boom, leaving me with L. What L equals is 32 times 2.8 over 6.28, parentheses closed, squared. Now, before I put that in the calculator, I want to find out how many round to the nearest hundredth. The nearest hundredth is 2 decimal places. So let's write that down. 2 decimal places. Okay, now I am ready to use my calculator. Oops, 32. Okay. Clear. 32 parentheses 2.8 divided by 6.28 close parentheses square. Enter. Now the answer should be 6.36. And it is! Yay! All right, let me do this. I'm going to copy that just so you can see it if you look at the notes. There it is. And then, of course, I am going to make it smaller. There. Okay. Now, round to 2 decimal places. I have to, here's the second decimal place, here's the first decimal place. I have to look over at the third decimal place to see if that's big enough to make the 6 round up to a 7. It's not. So I just forget these guys and I go with about 6.36 feet. Because remember, we're finding the length of the pendulum. It's going to be about, or really close to, 6.36 feet. Yes, it is. And that's it.